My name is Barry Smart. Good afternoon. I work for Engine. We're a boutique technology consultancy, fully remote. We're based here in the UK, but we work with clients around the world. We specialize in helping small teams to deliver cloud-native apps and data solutions that have high impacts in the organizations within which they work. And I'm going to talk to you today about how to develop high-performance data teams based on nearly, but not quite, 30 years experience in the tech sector. So a little bit about me first. I started my career as a graduate software engineer. I worked in the water industry. I was lucky enough to spend 3 years in Australia working for Sydney Water. I then came back to Scotland, where I'm based, and worked for Scottish Power in the energy sector, where I took on the role as chief architect, and then I did a stint as a business transformation manager, and then I was promoted to IT director. I then changed sector, went into financial services, where I helped digitally transform a 100-year-old financial services firm, and I was promoted to CTO for that work. I then changed gear to follow my passion, which is data. I studied full-time for a year, completing a master's in artificial intelligence, and I'm now at Engine, where I'm director of data and AI. So I've been a team member, a team lead, a departmental lead, an organizational lead, an exec, and now at Engine, I help to mentor our clients on, well, one of the aspects is how to build high-performance data teams, and I want to share my insights with you. When I'm not working, well, that's a big scary photo there. I told you earlier, I'm based in Scotland, so I enjoy exploring the Scottish countryside on my mountain bike, doing long rides out into the wilderness, so that's what I get up to when I'm not busy at work. So the first thing I wanted to talk about is that data is a socio-technical endeavor. By that I mean, to be successful, you need to master the human, organizational, and cultural aspects, as well as the technical aspects to succeed. Now this model is simple, but it fits any data project. You've got the data team on the left, the data product that they create, and the users on the right. So value flows from the left to the right. And what's also important is that there are feedback loops in place. And these feedback loops are important because they allow the data team to stay in touch with the evolving needs of the end users and keep the data product up to date as a result. And where that flow of value breaks down, or the feedback loop breaks down, there can be significant consequences for the data team. Another significant thing to consider in any socio-technical system is Conway's law. How many of you are familiar with Conway's law? Have you come across it before? Just one or two, okay. So it talks about this kind of so-called homomorphic force, which means that the organizational lines of communication will prevail over the software architecture that you're trying to build. And that can have negative consequences, obviously, in what you're trying to achieve. And I wanted to bring this to life by telling a story. So I told you earlier I used to work as a CTO in a financial services organization, and we had a new exciting opportunity. We wanted to take a new digital proposition out direct to consumers. The idea was that we would give consumers what was kind of fashionably called at the time robo-advice, allowing them to interact with an online tool to help them plan for a better financial future. So it was a really exciting project and a real opportunity for the firm to diversify into digital products and services. And we had a really strong vision for the architecture. This is a kind of simplified version of it, but you get the idea. We wanted to go cloud first, so we were adopting platform as a service. We're actually the first organization in the UK, financial services organization in the UK, to put personal data on the cloud. And that took a lot of work in its own right. But we had a vision. Our vision was to build a modern .NET architecture with microservices to wrap up the core intellectual property, this financial model, and allow the users to interact with it over an interactive web application. So we had a really strong vision for the architecture, but what we failed to do was think about the organization and how it was set up to deliver this architecture. And I'll illustrate that by overlaying now the organization, the stakeholders, the teams that were going to be that got involved in delivering this architecture. And you can see it immediately gets quite complicated. For example, we had an independent test team. So the developers had to hand over their software to the test team to be tested. The testers tested the software, and then they had to hand over all of the observations that they raised to the development team so they could investigate and determine whether they needed to be fixed. We had a deployment team, again, who were independent. They were gatekeepers of the production environment for good reasons, separation of responsibilities and all that good stuff. But they ended up being a massive bottleneck. Their engineering maturity was really low, so releases became pretty fraught and a massive ceremony. And we lost confidence in releasing, so we could only really release once every quarter rather than once every week, which would have matched the kind of agile cadence that we wanted to adopt. So you can see these are just two of many examples where the organization was working against the architecture, and the organization won, and that's pretty much Conway's law in a nutshell. So what this means was that we had a fragmented communications driving a fragmented architecture and a flow of value that was really lumpy and bumpy. And the product owner had to spend a lot of time facing inwards within the organization, managing this flow of value, rather than looking outside the organization and thinking about the user needs. And honestly, looking back, I think we could have achieved twice as much, 10 times as fast, with half as many people if we'd thought about the organizational model and designing something that matched the architecture that we wanted to deliver. So the consequences of this were the feedback loops were really never in place. The product owner was too focused on trying to get features out to the users. And we, after a few years, having spent a lot of money, and having only really onboarded a few users, we decided to retire the product. So I think this moral of the story is ignore Conway's law at your peril. It can have massive negative impacts on what you're trying to do in any technology setting, and that applies to data teams as well. So, sorry about my cheesy animations. So, high-performance data teams, that's what we're talking about today. They're highly aware that they're operating in a socio-technical system. And I want to speak briefly about some of the traits that they adopt, four traits actually, that they adopt to harness the forces of Conway's law and the socio-technical system that they're working in for good, and harness them in a positive way. The first trait is that high-performance data teams tend to be small and multidisciplinary in nature. By small, the magic number's around 7 to 9, depending on who you listen to. Or if you listen to Facebook, it's 2 pizzas. Basically, they say that they limit their teams to a team size no bigger than you could feed with 2 pizzas. Depends on how big the pizzas are, depends on how hungry they are, but you get the idea. But this is all backed up by research, okay? Anthropologist Robin Dunbar analyzed social interactions, and so that number is based on the research that he did. So a small team means that you can have a flat structure. The team can be self-organizing, and it can adopt agile practices. By multidisciplinary, we mean that the team's got all of the skills, and they're empowered to discover, build, and own data products through their entire end-to-end life cycle. So what do we mean by multidisciplinary? What are the skills that you need to hire for? When you look online, there's lots of advice out there about building data teams, and it's interesting, these are the kind of skills that they'll typically suggest you need to hire for. And there's no doubt you're going to need some of these skills in your data team to succeed. But the problem I have immediately with this is it's suggesting you need, people with very narrow technical skills in the team. And immediately you can see you're at risk of creating handoffs, even within the team, and incurring the wrath of Conway's law, the negative side of Conway's law. So a small team effectively forces you to hire people with more rounded skill sets. You don't want people who are deep technical experts. You want skills to be more rounded and for the skills across the team to overlap. You want the people in the team to be wearing multiple hats. And we like to say that you should be hiring for attitude over aptitude. So you're hiring people who are motivated to learn. They want to see the team succeed. They're not just stuck in a technical rut and want to use one technology. Attitude over aptitude also means you're hiring people who show leadership without being given a badge or a title. They think strategically. They're interested in the organization that they're working in. They want to use data for good. So that's something we fundamentally believe, and certainly that's the way we hire at Engine. So how do you build a data team? And I wanted to give an example of a client that we've been working with for about 2 years. The organization's medium-sized, they work in wealth management, and the exec team had decided that they needed to be more data-driven. So they hired, I'm trying to think of his real title, I think it's Head of Business Intelligence, but we're calling him here the Chief Data Evangelist, because that's exactly what he actually does. He's not a deep technical expert. He's worked in the industry. He's got experience delivering data projects over the last 10 years. But what he's brilliant at, first of all, he's a great team leader. He really inspires the team, supports them, protects them. But the thing he's really good at is facing outwards into the organization and helping them to understand the value that the team can deliver. He's influencing the strategy, and he's really great, in particular, engaging with the execs. And he's not afraid to say no as well. He's a great role model, and he really drives the team in the right direction. So he joined the organization, and he inherited an aging data warehouse that this DBA was managing and bravely trying to keep running. So she was his team member number 2, effectively. And it was clear that the data warehouse was going to have to be end of life. They needed a new platform. So that's where we came in. We kind of engaged at that point, and we worked with the team for the first 3 months. We kind of, an Engine squad, worked with the team. We delivered a new cloud-native platform. It was Synapse in this case, and then we worked alongside the team, upskilling them and delivering the first few data products on the platform in those first few months. And it's quite interesting. A member number 3 appeared. They were actually a domain expert. So the first data product we delivered, we identified someone in the business who was really high potential. They were really data literate. They were basically an Excel guru, and they showed a real interest in pivoting into a data career, and they wanted to learn new skills in doing so. So she joined the team quite early on. And then our chief data evangelist, also being a kind of entrepreneurial kind of chap, tapped into the firm's graduate recruitment program. So he pulled in a maths graduate to join the team. And then about 9 months into the life cycle of the team, they identified that they were missing some key skills around their engineering maturity was low. So they were using Azure, and they wanted to do more on automation, and they recognized that they could do with someone with more software engineering skills to look at the code and look at reusability and building up IP and all of these kind of good things. So they hired a software engineer. And that team, 2 years on, we've kind of worked intensively with them for the first 3 months, and then we've been kind of retained on what we call a brain trust. So we spend about 2 hours with them every week. So we help them unblock issues and build up new skills. But it's been amazing to watch how the team has grown. They've gone through that norming, storming, forming, and they're now a high-performance data team, and they've delivered a range of different data products into their organizations, having a massive impact. So I think this story is all about, you don't have to go out there and hire these rock stars. If you've got a bit of patience, you can build this talent yourself inside your own organization. Okay, so the next trait that we see with high-performance data teams is that they adopt a product mindset. And this is really useful. To think of what you're producing as a product is brilliant. It encourages you to look outward, to really understand, the users and their needs. And it's all about, rather than being an order taker, sitting there waiting to be given work to do, you're out there actively trying to find ideas that can transform the business. and challenge the status quo and deliver a massive impact. So, this is all about understanding the total cost of ownership versus the value of the product and being prepared to sort of pivot or fail fast early in the life cycle of the product. Product teams also shape their backlog. They reserve space in their time to do some of the more proactive stuff because they know they're going to own the product over its life cycle. Potentially, for example, releasing it hundreds of times over its lifetime. They're incentivized to invest in staying on top of technical debt and investing in automation. So that product mindset sets the team up for long-term success. The third trait is that high-performance data teams have a high degree of engineering maturity. So they bring in practices and tools from mainstream engineering and put those into good effect with one objective: to achieve rapid and safe delivery of value. There's a couple of things on here, but non-functional requirements are really interesting. It's a good practice to have when you're early, in the life cycle of any data product, to understand those non-functional requirements, things like security, scalability. These can also be extended into areas like master data and governance, and it allows you to build those things in from day one, rather than trying to do it later in the life cycle when it's more expensive and riskier to do so. And I think the data tech landscape's matured significantly in the last 5 years, so certainly with the cloud-native platforms, it's entirely feasible to achieve a high engineering maturity. And the final thing that high-performance data teams do is they help the wider organization become more ready to adopt data products and to be data-driven. So they engage, first of all, with their technology peers in ways that enable them to engage but don't interrupt the flow of value. So you hear about enabling teams that come in, a bit like Engine were doing earlier when I explained, to come in with some expertise to unblock an issue, or platform teams who are providing a capability like a platform or a service via an API or a command line. So they find ways of working with their peers in ways that don't interrupt flow. We also talked about the product mindset and how that engagement with users is really important, but they figure out, in doing so, they establish what we call a ubiquitous language to enable them to be more effective, and sometimes that can have implications, positive implications for the wider organization.